The next plenary speaker is Mr. Yoshiyuki Miyabe. Mr. Yoshiyuki Miyabe was born in Osaka, in Japan. He received a master engineering degree in '83 from the Osaka University, majoring communication engineering. That same year, he joined Matsushita Electronic Industry Company, currently known as Panasonic Corporation. During his tenure, he engaged in research and development of multimedia technologies such as hypermedia, digital cable TV, and digital satellite broadcasting. In 2003, he assumed the position of Director of the Corporate R&D Strategy Office and the R&D Academia Collaboration Center. Since his appointment in 2008 as Executive Officer, he has been responsible for strategic planning and management for digital network and software technologies and new business development. At present, Mr. Miyabe is holding the position of Managing Director, Member of the Board, and Chief Technology Officer. Mr. Miyabe.
Thank you, Professor Naota. Good morning, everyone. I would like to express my sincere thanks for the opportunity to make a speech at the plenary session of this historic ISSCC, particularly in the year of its 60th anniversary. This picture was taken at Fisherman's Wharf 21 years ago. The young man on the left side is me. I've had a lot of opportunities to come to Silicon Valley, but I haven't been a Fisherman's Wharf since then. This time I was looking forward to having a dinner there. However, I have to attend a board meeting connected to Japan tonight, so my dinner has been postponed. Putting that aside, today I would like to talk about smart life solutions, one of the key directions that our electronics industry is taking. This is the outline of my talk. First, I will look back at the evolution of consumer electronics, after which I will describe the concept of smart life solutions. Before concluding, I will show you a short concept video of smart life solutions. First of all, I would like to touch upon some of the social challenges that the world is facing. Before 2030s, we will have an energy bottleneck and changes in lifestyle. Global consumption of electricity will increase year by year. There have even been reports that we will need 2 Earths for resources and CO2 absorption. Populations are aging all around the world. In Japan, 30% of the population is 65 years old or older. In America, 20%. And even in China, 15%. Urbanization is accelerating. More than 80% of the population in advanced countries is concentrated in cities. Our electronics industry has to play a role in solving these social challenges. By using information and communication technology, we will combat the energy bottleneck through intelligent and comfortable energy savings. And we will ease the difficulties of lifestyle changes through individualized products and services. These are the smart life solutions I envision. So I would like to look back on the evolution of consumer electronics. First, let's look at the microwave oven. This slide shows the evolution of our company's microwave ovens. The vertical axis shows the ROM size of the embedded microcontrollers. We launched the first household microwave oven in 1965. The oven started to be equipped with microcontrollers in 1977. With the inclusion of even more powerful microcontrollers, over time, These microwaves were able to offer voice guidance, bread makers, and automated cooking. The ROM size also increased along with the functionality. In this way, microcontrollers have enabled the evolution of microwave ovens from simple heating machines into automatic cooking devices. Next, I'd like to look at the history of televisions. In 1953, our company released a black and white TV equipped with 22 vacuum tubes. In 1960, our first color TV had 27 vacuum tubes. We developed an all-transistor color TV in 1970 with 70 transistors. During the late 1970s, the TV advanced to cope with the new broadcasting standards for satellite, high definition, digital satellite, digital terrestrial, and 3D. As shown in this figure, the evolution of integrated circuit and digital signal processing supported the evolution of TV functions. As shown in the slide, the first TV were monofunctional and had only a few switches. Buttons on remote controls have also increased over the last 60 years. So, what will happen when TV advances even further? We will end up this remote control like this? That will not be in the case, will it? No. Instead, we will give you a magic wand to fulfill your wishes. This is our vision of the next TV. We will plan to call this Your TV. Your TV will provide new TV experiences optimized for you. It will offer personalized and customized functionality for your home screen, your program guide, your friends, and your recommendations. Your home screen will be displayed when you say, "My home screen," using internal cameras and face recognition technology. You can customize and personalize your favorite content and applications on your home screen to access them easily. The social networking capability allows you to share your favorite TV programs and chat with your friends. So now I will explain the systems that will make your TV a reality. Your TV is a new smart TV that communicates bidirectionally over an IP network. This system is connected to content providers, friends, and advertisers on the cloud. It provides the most appropriate services to users by accumulating user taste and user logs. The TV is implemented through a full HTML5-based systems, including on-screen display, user interface, and applications. This enables the system to continuously update the newest functions. As the last topic on the next generation TV, I will introduce the example of SoC required for these TVs. In internet transmission, the available bit rate changes depends on the network conditions. The TV must be able to handle this. At the same time, the TV also has to process feature-rich OSDs and applications written in HTML5. We developed an SoC for smart TV named PH1 Pro 4 to handle these challenges. It includes a media processor and DDR3 interface, complete with a hardware multi-thread mechanism and 4K 2K ready multi-codec with adaptive bitrate control. The SoC is built on 700 million transistors with a 40 nanometer process and run at up to 1.4 gigahertz. So far, we have reviewed the evolution of consumer electronics. As shown in this slide, we have achieved convenience such as automatic cooking with microcontroller CE, entertainment such as HD and 3D with digital CE, and social networks such as social TV with smart CE. We will then innovate the consumer electronics even further. Specifically, in addition to AV devices, we will network home appliances and energy equipment and connect it to the cloud. Doing so will allow us to achieve services that have not been possible with standalone devices, because the devices will exchange information and work together. We will call these ecosystems smart life solutions. In our envision, CE will enable comfortable and delightful lives. Next, let's look into the system architecture. In the embedded system, software and data are combined and processed internally. How about in smart life solutions? Smart life solutions are achieved with systems architectures based on the cloud and machine-to-machine transactions. Then, applications are implemented with software and data, which are distributed across CE devices and the cloud. The communication network in smart life solutions corresponding to the system bus is embedded in the systems. So, communication technology becomes increasingly important with smart life solutions. Wi-Fi coverage is expanding for short-range wireless communications. With the evolution of M2M, even greater volumes of data will be exchanged at higher speed and with less energy. Millimeter wave-based WiGig is expected to become a standard for short-range gigabit wireless communication. WiGig or 802.11ad, an expanded Wi-Fi standard, will not only achieve high-speed wireless communication, but also high energy efficiency. WiGig consumes 1/10 the energy per bit than 11N does. We developed a chipset based on WiGig and 11AD, providing a total solution from RF to Mac, and with built-in self-calibration for cost effectiveness. The chipset operates at up to 1.8 gigabit per second, burning only 0.56 nanojoule per bit. We will present this work in section 13.1 tomorrow. In the next part of my presentation, I will explain some specific examples of smart life solutions based on home appliance cases. Using an NFC-enabled smartphone, these appliances are connected to the cloud. The washing machine can learn from the cloud the optimum wash program for detergent and fabric softener being used. The refrigerator can check the past power consumption history. The microwave can download the cooking recipes. The next slide demonstrates an example of application of the weight scale and activity meter. The weight scale and activity meter record a log on the user's smartphone and upload to the cloud. You can share the log with your friends and manage your health with a game-like feeling. In addition, you can download the recommended recipes based on the log. You will probably also able to forward these recipes to your microwave. This figure shows the configuration of our home appliances connected to the cloud via a smartphone with NFC. The smart appliances contain both microcontroller and NFC LSI with the specification as shown in the slide. When users hold their NFC smartphone over an NFC appliance, the smartphone application read and write the information to and from a smartphone via an NFC chip. At the same time, it synchronizes the information with data on the cloud. In addition to appliances, we also connect makeup mirror to the cloud. This is a smart mirror composed of an LCD and dimmable LED, a camera, and non-touch skin sensor. The mirror diagnoses the condition of your skin using digital signal processing that analyzes the RGB image, polarization image, and tissue image. Approximately 10 GOPS is required for this signal processing. The mirror then guides users on makeup and skincare based on their skin data accumulated on the cloud. Next topic is the smart energy. We are achieving smart energy by using 3 approaches. Approach 1 is energy-saving appliances with adaptive control using environment sensing and human sensing. Approach 2 is energy management system, EMS. We are introducing energy creation, storage, and management into homes, retail stores, and apartment and office buildings. Approach 3 is the Smart City project. I will now explain the home EMS or HEMS. The brain of the EMS is SEG or Smart Energy Gateway. The SEG gathers information related to energy from appliances and controls the appliances autonomously. The SEG is also connected to the cloud. The cloud gathers information not only from the household, but also from surrounding environment. I will now introduce an example of these services might be like. This example demonstrates the cooperative control of the ideal energy mix based on live logs and weather forecast. Step 1, the HEMS estimate the power consumption of the household based on the live log. The chart on the left shows a sunny day, and the chart on the right shows the rainy day. On rainy days, they use a clothes dryer in the morning. Step 2, the HEMS estimate as solar panel output using panel log data and weather forecast. You can see this in the green areas in the 2 charts at the bottom. On rainy days, the solar energy output is very low. Step 3, based on these estimates, the HEMS create a plan for power supply and charging and discharging. On a sunny day, solar energy output in the daytime is stored into the lithium-ion battery and is used in the evening. Part of this output is sold to the grid. On the rainy days, the system charges the battery with cheap nighttime power in advance. This is used for the clothes dryer in the morning and power consumption in the evening. As I mentioned, the HEMS uses live logs and weather forecast to optimally control power generation and storage equipment. The last approach for the smart energy that I will mention is the Smart City project. We are expanding a scope of the EMS to urban development. We have projects in Tianjin Eco-City, Singapore, Dairen Best City, and Fujisawa Sustainable Smart Town in Japan. Next topic is the connected car. In this concept, car will be connected to the cloud, road infrastructures, and other cars. This will achieve a safe and comfortable driving environment. In recent years, due to the spread of smartphones and built-in 3G modules, the number of cars connected to the cloud is increased. In the near future, C2I, car-to-infrastructure, and C2C, car-to-car communications, will lead safer driving environment. Now I will introduce some examples of services provided by this C2C and C2I communication. According to Japanese report, 54% of accidents occurs at or close to intersections. One main cause of these accidents is poor visibility at the intersections. Therefore, it will be possible to avoid accidents by improving visibility with C2C and C2I communications. A car will exchange position and direction information with other cars, or receive information of pedestrians, bikes, and road conditions from infrastructure sensors. When it decides the situation is dangerous, it will sound a warning or invoke collision prevention assistance. Furthermore, on expressways, sharing control information among multiple vehicles will enable automatic cruising information. In addition to enabling safe and comfortable cruising, this may also prevent traffic jams. This slide shows the requirement for C2C communication, where high speed and low latency are essential. In this example, we must complete authentication and data analysis within 0.3 seconds for all 100 cars approaching at once. We also have to budget 4 seconds to allow 33.7 seconds after the analysis for alert and accident avoidance. Standardization of C2C and C2I being promoted in the USA, the EU, and Japan. The standards differ from each other due to the transportation characteristics in each region. But the OFDM and access method are the same in all regions. From our standpoint as a device maker, we hope for the development of globally compatible SoCs that encompasses all of these specifications. This will help us to develop common applications where we have to implement high-speed, low latency, and robust software while examining communication performance. In future smart life solutions, each CE device will be intelligent, and agent will proactively control all of the CE devices to support people in living comfortable and delightful lives. Recently, such M2M computing has been called fog computing to contrast to cloud computing. We are researching agent technology for smart life solutions, and we call our agent CAROL, which stands for Computer Assisted Residence for Your Optimal Life. I will now show you a concept video of future life solutions. Please enjoy it.
Will you be late tonight, Mary?
I don't
think so.
All right, see you later.
Bye, John.
I'll talk to you later, Carol.
Okay, Mary. John and Mary have left. Enter power-saving mode. It's a special wine for John's birthday today. I'm sending you a procedure for optimal temperature control. Please learn it. No, wait. You can start at around 1 or 2 p.m. when the sun comes out.
Hello?
How's work, Mary? I'm leaving the office now.
I have to work late tonight. Sorry. Is it okay if you come home around 7?
No problem.
I've got to hurry.
Hey, wanna go out for some drinks?
We're busy tonight, John.
Okay, maybe some other time. How can I kill some time before I go home?
Mary will arrive in 30 minutes. Are the flowers I ordered ready?
Yes, of course. They are ready for pickup.
Here is the bouquet that Carol ordered.
Thank you. Oh, bummer. How am I going to beat this traffic? Carol, help me. I need to be home by 6.
No problem, Mary. Here's a detour route. Your arrival time will be 6 p.m.
Okay, I'll take your advice. That's a big help. Carol, are you all ready for tonight?
Yes. I'm heating up the house and preheating the oven. Drive carefully. The road is icy.
All right. I still have plenty of time. Carol, start cooking the chicken.
Sure, Mary. You can leave everything else to me.
Carol, where's John?
John is at the BART station. He will probably be home by 7 p.m.
Is the stew ready?
Yes, the stew looks just right.
How about the wine?
The wine is chilled to the correct temperature.
And what about the music?
John's favorite songs are ready.
Carol, I'm back. Hey, Carol. Come on, turn on the lights. Something's not right.
Happy birthday, John.
Did you enjoy this smart life? I did, as John. This video may look simple and natural, but as technology becomes more and more complicated, this is crucial to be conscious of the human user and create interfaces that are both easy to use and delightful. Okay, let me move on my conclusion. This figure shows our broad areas in which we will provide products and services as an electronics company: residential, non-residential, mobility, and personal. A human customer is always at the center. Consumer electronics have progressed through the microcontroller C, digital C, and smart C stages. Next, we will see smart life solutions, which we will realize through M2M and cloud computing. All devices in these 4 areas will become intelligent and interconnected. This will be achieved with innovation in processors, DSPs, sensors, and communication components, all of which are the semiconductors. I believe that semiconductor technologies are key to innovate and have infinite possibilities. Now, this brings me to the end of my talk. Thank you very much for your attention.